Hello, good afternoon. Kumar sir. Hello. Kumar sir. Sir, you're able to hear me, sir? Am I audible?
Jafar sir,
Hi, sir. Good afternoon.
good afternoon, sir. Sir, just 10 minutes, students are getting now. We have left last session very late.
Hello.
Sir, can you hear me?
Yeah, now it's audible, sir.
Students are coming, sir. They are joining after lunch. They are coming here. Just
Okay,
10
okay.
minutes. We'll start.
Sure, 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 sir.
Jafar sir, shall we start?
Yes, sir. Dimin.
Yeah. Welcome all the participants and third day last session. We are approaching the end of this workshop. So in this, I would like to introduce a speaker. Mr. Jafar from Task Telangana State Skill Development Department. So it is for honor for us to invite you for this program, sir. So now I invite you for giving a special lecture to the students and participants who are in the online and offline. Welcome you, sir. Now the session is yours.
Oh, thank you so much, sir. Thank you so much. Sir, is my screen visible, sir? And I am audible?
Yes, sir. Yes, sir.
Right. So, good afternoon, everyone. Thank you, Kumar, sir, for giving this platform to disseminate the knowledge that we have. Now, let's get directly into the concept. See, dear, you might have learned till now these concepts of IP addressing and all. And let me start my exercise. Now, let's say suppose this is a router 1. Okay. Now, we also have one switch. Okay. And all these three hosts or nodes or end devices connected to a switch. Now you have started your journey by making this particular PC1 to communicate to this PC6. If I name it as 1, 2, 3, 4, 5, 6. So it is easy for us to communicate between PC1 to PC6. But it happens only when you have same range of IP address. Let's say suppose 10.1 is here. Now I also provide this same address as 1.8.10.2, the same series. Then it is easy for us to communicate between this particular LAN and this particular LAN because it works within the same PC. Now slowly we moved in such a way that now my series changed to 10 to 20. Okay. Now if I happen to work with the different lines which are connected into a different networks. Now can I do that? No. In order to do it, what we did is we started talking about static routing. We might have, that means in a simple way, we might have focused on routing protocols. We have focused on routing, in which one case was the static protocol. Okay. Then we also do it by using the dynamic routing protocol. When we do this, not only with this, now we can also do with, because the router is a layer 3 device. Now we also have a switch which is also a layer 3. With that also, this particular thing is possible. But when we use the what we call layer 3 switch, when we use layer 3 switch, then we have to work with multiple commands like switch code, blah, blah sort of things. But when it comes to the layer 3 device, which is a router, then it is easy for us to configure the routing protocols, name it to be as a static routing protocol. This is what we have seen with static, which is nothing but a manual, which is nothing but a dynamic. Now, little forwarding a step, little forwarding a step. Now, to make that happen, same this dynamic routing protocols are now divided into IGP and EGP. Same this dynamic routing protocols are now classified into IGP and EGP. Now, to my knowledge, I believe that you might have also configured something called as a RIP. Right? You might have configured a RIP, different versions of it. But when you talk about your IGP protocol, now this is a protocol which will talk about distance vector routing protocol. This is talking about distance vector routing protocol. Okay. Now the same IGP is also speaks about link state routing protocol. Both things. Right? Because why is that? Because it works within the multiple, because it works between the multiple networks. Because it works only within the one. Please make it a note. It works only within a multiple networks. Inside the multiple networks. So we have something called as a distance vector routing protocol can be executed, or the link state routing protocol. Okay. Now we'll come back to EGP after some time. Now, when I want to talk about distance vector routing protocol, there I am licensed with something called as RIP. Okay, and different versions of it, which is a IPv4 classless and everything. Now, today's class is nothing but IGRP. After RIP, then there is something called as interior gateway routing protocol. Under interior gateway routing protocol, we have today's concept called EIGRP. We have something called as EGIR. Now, let us understand why I am using this particular EIGRP protocol. As said, I also shown you the topology stating that when we have two different networks, if I want to talk to them, then the routing protocol comes into the picture. Now, to solve those type of scenarios, I will be using one of the protocol called as IGR. This is what which I will be using it. Now, basically, see my dear, EIGRP is a protocol. EIGRP is a protocol created by CISCO in 1992. It is created by CISCO and it's CISCO own proprietary protocol. It's a CISCO own proprietary protocol. But why is it created, sir? Why is it created? Because we have few slow processes with respect to the RIP. We have a little slow processes with something called IGRP. Used to work very, very slow. To make it little faster, to make it a little better version of it, then we had something called as the enhanced IGRP. Whatever this IGRP used to work, a little better version was derived with the name called enhanced IGRP. There we have IGRP, EIGRP comes into picture. Right. Now, when they in 1992 when it was created, no, it used to work only on CISCO devices. It only works on CISCO devices. But later, after 2013, it started working on the other devices as well. But only on the partly basis. The full it supports on CISCO devices, but partly it supports on the other devices. Because that EIGRP is created, the reason, there are different reasons. One, it is known for its fastness. Okay? It is more reliable, and it is very, very easy to configure when compared to OSPF, RIP and all. Very, very easy to configure. Okay? And the beauty of your EIGRP is it also chooses its best fit. It is very smart in choosing its best route. Where IGRP and the RIP are little slow when compared to EIGRP. Okay. See, this is a small, and if you want to talk about its advantages, it's very fast convergence. It uses into multiple metrics. It is, when compared to OSPF, it is very, very easy for us to configure. Okay. All right. Now, please remember this particular topology. Now, let us directly move on to the, what we call, the practical part of it. Let us directly talk about the practical part. See, what we are going to do now here is, now let's see how do we communicate between different networks. To make that, let's have a small topology executed in the packet trace activities. Now, first ask is, let us draw a topology. Let us draw a topology. Okay. Then second, let us also configure the required IP addresses and all for those particular topologies. And then third one, now let us see how do I configure my EIGRP, and let's see how do I work with my EIGRP. The fourth one, we shall test, right, whether it is properly configured or not. These are the 4 steps that we are going to see in the today's exercise. Now my packet tracer is open. Now I'm told that most of you are also having your laptops. So I would request all my friends to open your laptops and open your packet tracer so that we will have 1 or 2 exercises of it to make it interesting. Right. In the packet tracer, to the down, let's talk about the network devices. So I'm selecting a router. Now click on to 2911 router model. Okay. One router. Let's also take about the other router. Okay. Let's say where is it? Taken 2 routers. Then let's take one more device intermediate switch. Okay. Now let me connect my end devices. Let me also use 1 or 2 end devices. Later you want to extend it, you can extend it. Okay. Now these are the devices which I. Now what? Let's go to the meeting. I'm taking automatic. Directly connects it. Connected. The same thing is with this. Now this has become one LAN bus. This is one LAN and this is one LAN. Now this LAN is now the connected. Go to gigabyte, 3 gigabyte. This is the other way. Choose the required cable. Okay. Now connecting both the rods with both the routers. This is one of the topologies. This is the network diagram. Let's say a basic network diagram for us to understand. Okay. This is now if you think about this is Right. Now let's have one IP address given to this. Now, if I want to assign an IP address, now let us use an IP address called as 192.160. Let us take one IP address, 192.1.0 network. Okay. Let's talk about 1.0 network. Now here 192.168.2. This is also one, the other network. Okay. We have two different networks. Now that means this particular association will work with this particular network series and with this network series. Okay. Now I have two routers. Now two routers, in order to communicate, we should also have one more IP address in there. Now let us also have one more IP address. 192.168. See, this is 1.0 series. This LAN is 2.0 series. Now both routers is now connected with 12. Series. Now let's look at this network. Okay. Now we have three different networks. Now we have three different. One switch and the router. Now this router has got interfaces. Now this router has got two interfaces connected to it. One is from switch and the other interface is connected to the other router. Now if I want to say it, okay, which interface is connected? This is gigabyte 0/1 and this gigabyte 0/0. Now for this gigabyte 0/0, since this is gigabyte 0/1, okay, this is very, very important because if you fail to remember it, then you are gone. So I'm just naming it for the future reference. Now what is this? Gigabyte 0/0. Gigabyte 0/0. Okay. Now, if I want to assign the IP addresses, now let's go ahead and assign the IP addresses at the gigabyte 0/0 and gigabyte 0/1, and same case is for router 1 and router 2 because we have both the routers. Now, the basic configuration, I believe you know how to configure the host names and console passwords and everything. Okay. Now, what I'll do is I'll just go to my router 1. Or let me also define the IP address so that you can also configure it at 0.1 at gigabyte 0/0. You can also assign 192.168.1.1. Let that be the IP address here. Now for this interface, now you write 192.168.12.1 here because it is 12 series. Now here also 192.168.12.2. 12.2. Now here we have, what is this series? 192.168.2.1. Let's talk about 2.1. Let's talk about 2.1. Okay. Now these are the 4 different IP addresses assigned to 4 interfaces of 2 routers. Okay. Now we also have to assign these IP addresses. Now we'll come back to the host IP address after some time. But let us go and assign the IP addresses for this particular router. To assign it, we have to click on to the command line and CLI, then go to no. You can do it either the way. Either you can do it in the GUI mode or the CLI mode. Let's work with the CLI mode. First command is enable. Okay, then go to config T. Now here is where we start configuring our router. Okay. Now I'll say host name as R1. This is what my router. Now I want to directly, I'm jumping to the configuring the IP address for the router. So I'll say interface, okay, then gigabyte at 0 by 0, okay, interface number. Interface gigabyte 0 by 0. Can we have IP address assigned as 192.168.1.1 and its subnet mask is 255.255.255.0. Okay. Then let's have no shutdown. No shutdown. Now that particular interface is now up. Exit. So one interface is configured. Now see, when the interface is configured, now color is turned to green. That is what the identification. Now second interface gigabyte 0 by 1. 0 by 1. Now the IP address which I want to configure is 192.168.12.1 and with its subnet mask as 255.255.0. Okay, then no shutdown. Both interfaces are now configured. Okay, but router 0, router 1. This is done. Now let's talk about this router. Let's talk about this router. Okay. Now here also I'll say enable config T. Now again same host name as R2, router 2. Okay. Now what I want to configure my interfaces. Now first interface gigabyte 0 by 0. Now what is the IP address for 0 by 0 was? I gave it as both. It is 0 by 0. It is 0 by 0. See. Be very careful which interface is having the which IP address. The series is changed, then you will not have the expected output. Okay. Now the command is IP address. Now provide 192.168.2.1 is the IP address which is assigned at 0 by 0 series interface. Then we have 255.255.255.0. Then social down. One interface is assigned. That's it. Okay. Now in the same way, similar ways, interface gigabyte 0 by 1 is left. 0 by 1 is left. Now here again you assign the IP address to this interface and the IP address here is 192.168. It is 12 series bus. Okay. Now same way 1.255.255.255.0. Sorry, no shutdown. Now all the 4 interfaces are up now. Okay. If you see the topology, network topology, there is no red mark available here. There is no red mark. Okay. There is no red mark. Now, if I want to communicate between this particular topology within this particular network, now let me also assign the second stage is, let's go to my host. Okay. Let's go to my host and now here 192.168. Now we have given 1.1 series, right? Now so I'll say 1.10. 1.10. And the IP address of this particular interface will be the default gateway to this particular system. The IP address of this particular interface will be the default gateway to the nodes or the end devices. Now, what is the IP address that I have assigned to that particular address? 192.168.1.1. That is what the default gateway. Okay. Now, similarly, the second PC also has the same. I'll write 192.168.1.20. Now, the same default gateway 192.168.1. Okay. What is the IP address here? For this particular 192.168.1.10 with 192.168.1.1 as the gateway. Now for this PC also 192.168.10.1.20 and its subnet mask is gateway is same as that particular PC. Okay. Now similarly, let's work with the other LAN devices. Okay. Here, now the series here is 2 series, 2.2 series. So now I'll write 192.168.2.10, then two, sorry, 255.255.255.0. Then go to the same 192.168.2.1. This 2.1. Okay, once is similarly, I'm going to the fourth one, 192.168.2.20. So it is already this, okay, .168.2.10. .10 is what I gave. It is 20, 192.168.1. Okay. Just for further future reference, I'm also writing here 192.168.2.10 and its default gateway is 160. Okay. So similarly, for this 192.168.2.20, 192.168.2.20. Now, this is what we have done. This is what we have done. So we have created a topology and we have also assigned the IP addresses within the network. Hope you are also doing with me. Okay. Now, when we have assigned the IP addresses, now if I want to communicate between this PC to the third PC, from one LAN PC to the other LAN PC, from one network PC to two network PC, and now I will be using the ping command. See, ping 192.168. What is the IP address of that? It is 2.10. I should give it. But it says that destination host unreachable. It says that destination host unreachable. Now this is not only with that. Now even if I write one ping 192.168.2.20, you have the same response because they are in a different world altogether. This is one world and that is other world. Now, but if I ping 192.168.1.20, you see, Because since that is in the same network, now we are getting responses. We are getting responses. 1.20, 10 can communicate to 20, but not in case of 2.10 and 2.1. In order to have the communication extended between the two different networks, now here is where the routing protocols comes into the picture. Here is where the routing protocols comes into the picture. Now, in which, now let's talk about EIGRP, extended IGP command protocol. How do I configure it? How do I configure it? Now, you have to tell this particular router 1, R1 router, saying that, hey, boss, you have the associated neighbors available with you, as you did for your OSPF. You have to tell him that you have the neighbors available with you, or you are in this particular dynamically assigned. Getting my point? Okay. Now let's go to the router. Let's go to the router. You have to advertise this particular networks. You have to advertise these particular networks. Right. You write here router. Now, which protocol you want to configure? You want to configure EIGRP. So write EIGRP. Okay. EIGRP. Then provide the question mark, because you got to write the AS number, which is nothing but autonomous system number, Okay. Which talks about the area basically. Now it is starting from 1 to 65,535. Okay. Now, what is the use of this particular autonomous system number is, this will help us to have the multiple devices with a single administration. I can manage the multiple devices with a single administration. Okay. So there I use my AS. Now that AS can be a private and the public again, private and public. So now what I have to do is I can work from 1 to 65535. 65535. So now see, I am assigning EIGRP. Now I'll say let's type it to be as 1. Let's begin with 1. Okay. That is 1 is nothing but AS, autonomous system number. Okay. Right. Autonomous system number, point number 1. Then now what I'll see, I am addressing, now I will be addressing the directly attached network. I will be advertising the directly associated network. So I told you, no, you should say that, hey, bhai, I am your neighbor and so I am your associated one. So to do that, what you have to do is you have to talk about the network. You have to talk about the network. Now, what are all the networks that you are attached with? You are attached with 12.0, isn't it? R1 is now attached with 12.0 and R1 is also working with 1.0. So now write 192.168.12.0. Okay, this is one network. You can also provide the wide card as well. You want to, otherwise not needed. 192.168. Then we also have the other series as network 192.168.1.0. Now both the networks have been advertised because they are directly attached to this particular network. Okay. This is the second one. Exit. Now, similarly, the way that you did for your router 1, please go back to your router 2 and also say router, I want to configure the EIGRP. Okay. Now the autonomous number, the autonomous AS number. Now remember one point, very important. Whenever we want to work with EIGRP, the autonomous number of this particular network and that particular network should be same. Autonomous number between this particular network and that particular network should be same. It has to be. It has to be. The condition to work with your EIGRP is both should have the same network. Okay. Is that clear? The process ID, which we say to be as a process ID, should be same. If not, it will not work because it creates the logical boundaries. And I have used one autonomous number there called as one. The same goes with your the other router as well. Because I told it has the association with multiple devices, isn't it? So EIGRP with the same autonomous number. Now there I'll say all the networks that are connected to this particular router. And to this particular router, we also have the same 12.0 is connected and 2.0 is connected. Now write the same network here. 192.168.12.0 is advertised here. See boss, EIGP. The neighbor is connected. It is showing. Okay. Now similarly, now I'll be doing it for the other network called as 192.168. What was it? 2.0. Okay. Now that's it. When you give this particular network, when you give this particular configuration, now EIGRP is enabled on both the routers. Now it will help you to route your packet from one different network to the other different. See, what was our result when I was talking to 2 series? See, 2.10, same ping state command 2.10. See. See, now it is responding. Earlier it was the destination host unreachable. Now since that we have configured the EIGRP extended protocol, now the result is before you. Now this is where we say it as a dynamic routing protocol has been established. Okay, the neighboring adjacency is what it gets established with. And EIGRP also has the what we call its administrative distance to be 90. Okay. Now this is how the EIGRP, and it also works with the dual algorithm. The main important aspect of your EIGRP is it has got a backup route available. It also has the best backup route available. Now, for example, you have 4 routers connected. For example, give me a second. Where is my pen? Now you have router 1 is connected to router 2 and connected to router 3, and this fellow is also connected to this particular router. Again, this guy is now connected. Now you have 5 routers. Okay. Now I want the PC 1 of this should talk to PC 5 of this. Example. Okay. So what are the distances that I can? So I can move from this end to this end and this end to this end, isn't it? Or I can also move from this end, or I can also have the association like this. So I have different paths that I can travel from router 1 to router 5 to reach PC 5. So for example, if this is blocked, it will say that it is dead, it is not alive. So it directly chooses its other path. So it has got the alternate path available with it. Because of dual algorithm. Okay. Now this is called your EIGRP. Simple. Hope it's clear. Okay. This gives us okay, the use of EIGRP. Why am I using the EIGRP? I might have used the OSPF, I might have also used the RIP, but now I'm using EIGRP because it has its alternate path the best alternative path available to data. Okay, and very fast when compared to OSPF. Now, this is all about a small concept of EIGRP configuration. Okay. Now, the other task which I am also told you to talk is BGP. Right. In the interest of time, I am being very, very crispy. In the interest of time, I am being very crispy. I was given just 60 minutes. Okay. So now we heard about this, and just give me let me go to this place where we discussed about the other. Now we were talking. We also spoke about those RIP protocol. Now here is the dynamic routing protocol. This is what we spoke, right? This is where we started our discussion. Now, when it comes to EIGRP, it should have the same autonomous system number for EIGRP. For EIGRP, it should have same autonomous number. Now, it is fast. So in general, it is like a Google Map for us. Google Map, just simple. Google Map is one of the examples that I can use for EIGRP. Okay. See, one road is blocked. We have a congestion. If you have a traffic in one road, so it also diverts us with the other road, isn't it? Now, the same work is with your EIGRP, but provided it should have a common autonomous system number. What if I have two different autonomous number? What if I have two different autonomous number? For example, R1, and we also have R2, and we also have R3. Okay? Now, similarly, now we have one device connected here, and we also have the other end device connected here. This is your PC1, and this is your PC2. Okay. Right? See, this guy is connected here, and this router is connected. Three routers connected. Okay. Now what happens is, now I have 192.168.1.0 network here. Now similarly 1.192.168.2 network here. But here I have 10.10.10.0 network here. Now I also have 20.20.20.0. Okay. Now little, because I have added one more router, so I have an excess IP address available. Now we have three routers available. Now I want to communicate between this PC to this PC. Yes, I can do that by using EIGRP. Isn't it? But it is only when we have AS number. The AS number for this area, the AS number for this one, and for this network should be same. The AS number for this network and this network should be same. It should be same. Now, if I say the AS number here is 10, now here also the AS number is 10, then I can work with the EIGRP. Supposing if my AS number here is different, then I talk about the other EGP protocol. But remember one thing. EIGRP is for small one. Let's say support one single ISP, internet service provider. But when I talk about EGP, it is like internet. It is open. It's very, very, very wide. Multiple ASPs get into EGP. Multiple ISPs can interact with each other. See, when I said ISP, we all have got internet. We might have the ISPs. Okay? Let's say suppose Airtel, BSNL, okay? And reach, blah blah. There are different service providers, internet service provider available across a different geographical location. Okay. Now I have, for example, I'm telling you, we have, for example, we have one Apple ISP, we have the other banana ISP, then we have orange ISP. Okay. When we have these different ISP, their AS number is common. Now here its AS number is different, and for orange the AS number will be different. Now the number of systems, let's say suppose 300 systems that are connected with the same ISP, same network, yes, it is possible. Now this fellow may also have 400 system connected, yes, but this fellow also has got 500 system, yes, it is connected because they are working independently. They are not dependent. Now you want to make them dependent. Now you want to make them dependent. Now you want to make them dependent. There we talk about EGP. There we talk about EGP. There we talk about dependent. But when we talk about one ASB, we talk about EIGRP. But when we talk about multiple things, then we talk about EGP. Now, under EGP, which is nothing but EGP is nothing but exterior gateway protocol. IGP is nothing but interior gateway protocol. When we talk about exterior, outside, right? Which again talks about path vector routing protocol, which is talking about path vector routing protocol. But whereas IGP, it is talking about distance vector routing protocol and link state routing protocol. Distance vector routing protocol and link state routing protocol. But when it comes to EGP, it only talks about path vector routing protocol. Now to define this path vector routing protocol, we have something called as BGP. This is where the concept comes in, which is called as broader gateway protocol. Broader gateway protocol. Okay. So very lengthy topic, but being very crispy for to make you understand. Okay. Now, if I want to configure the BGP, now let me show you. One example, sir. R1, R2, R3 router connected. Okay. Very simple. Now, just now I told you the one. No, let us do it on the packet tracer instead of doing this. See, let us take one router here and same 2 double, also remote 3 routers. Now 2 switches for one LAN. Now, let me also add one more computer here in devices. Okay, sir. Now let me go. Can you please connect this to fast Ethernet and 0? Similarly, take one more. What happened? Connected. Take the same thing. Believe that you are also doing it with me. One switches between. So what I do is let me connect that to both the gigabytes, so that will not have any issues here. Same put to same put. Okay. Now go back here. Take the same thing 0 by 0 to connect here to 0 by 0. Sorry. You can also do that, but let me use the crossover cable. Crossover cable between 2 routers because they are identical devices. Okay. Now this is one of the topology. But now, to make you understand, this is one. This is the other one. Okay. Let's talk about this. Now we have three. Now, same case, boss. Same case. Now let's have the IP address for this one network. Let's say suppose 192.168.10.0 one network. Now here I'm writing 192.168.20.0. Okay. Now here I'm going to be as 10.10.10.0 network. Now here let me talk about 20.20.20.0. Okay. Now we have 4 in networks IP addresses now. Now let's also configure the which IP address to this. If I say 192.168.10.1. Okay. Now here I will say it as 192.168.20.1. Okay. Now here I'm saying 10.10.10.2. Okay. 10.10.10.1 here. And write 10.10. Sorry. 20.20.20.1. 20.20.2. Okay. Now, if I want to see, okay, what is this? 0 and this is 1. So right here, this has gigabyte 0 by 1, and this has gigabyte 0 by 0. Okay. Now similarly, go here and check this out, this interface as well. Because interfaces are very, very important. If you chose one interface and the other interface while doing your CLI configuration, then you are wrong. So for that reason, this is 0 by 1 and this is 0 by 0. Now take again the placeholder. Keep here. We'll say that this is your 0 by 1. And this IP will be for your gigabyte 0 by 0. Okay. Now here, when it comes to here, see, it is 0 by 0 again, it is 0 by 1. So take the other placeholder, you say that this is your gigabyte 0 by 0. You say that gigabyte 0 by 1. Chalo. Now, this has a perfect structure now. Now you know the IP address here. For example, you write 192.168. Since it is 10 series, so I'll write 10.10, right? Then you write 10.1 as the default. Okay. Now similarly for this 192.168.20.10, then you write 192.168.20. Right? Yeah. Now this is what we have. Okay. But remember here, for EIGRP, we have given the AS number as 1 here, and we also gave AS number as 1. Okay, for EIGRP. But when it comes to the EGP, now let's say that it is 10, and let also define it as with a different AS number per 20. Okay. Now this area is with 10, this area is with 10. Now this also is talking about some area, so it should also have one more AS number. So AS number at 10, and let's say it was 30. ASS 10, 20, and 30. You can name it anything. I can say it to be as 20, 50, 35, your choice. Okay. Now we have different A's and different IPs. Now let me directly dive into the configuration. Okay. CLI, say no. Okay. Enable conf t. Now provide the IP addresses. Go ahead by providing the IP addresses for router 1 and router 2, like interface gigabyte 0 by 0. Check this one. For gigabyte 0 by 0, I have an IP address as 192.168.10.1 with subnet mask as 255.255.0. Sorry, I didn't give you. There is no dot. Okay. Then write no shutdown. Come out of that interface and write one more interface called gigabyte 0 by 1. Okay. Now here you are typing it with IP address as 10.10.10.2 and it's subnet. Now I'm saying it as 250 because /30 network. Okay. And I'm making this for minimum next hooks connected. Okay. Now one router is completed. One router is completed. Now again, click onto this configure same enable conf t interface gigabyte what is it? It is 0 by 0. Then my IP address will be 192.168.20.1 with subnet mask as 255.255.0. Then you shut down. Okay. Come out of the interface, like one more gigabyte, then it is 0 by 1 interface. Now for this interface, I am assigning the IP address, and that IP address is 20.20.20.20.82 with the same subnet mask as we did for 10. Let's say it is /30. Then close it down. Exit. Okay. Now I have assigned the IP address for TrueNet. Now similarly do it for this router as well. I'm just assigning the interfaces first, IP addresses to the interfaces. Then I'll come back to the EGP. Enable 150. Sorry, sir, I'm taking little time. I can continue, right?
Yes, sir.
Thank you, sir. Here it's 0 by 0, and we have 10.10.10 IP address, like 10.10.10.2 one with subnet mask 252, push it down, come out of the interface and assign one more interface gigabyte, what is it, 0 by 1, and then IP address as 20 dot. Sorry. Oh, it is the subnet mask is only given. Right. Interface gigabyte. Twenty dot 1, 255.255.252. Right. Push it down. Fine. So we have now assigned the IP address for all the interfaces. Now all the links are now off. All the interfaces are now off. Now I want to talk to the PC1 to PC2. Okay. Now go to this and assign it to be as what was the IP address? 192.168.10.10. Okay. Right, 192.168.10.1 is the default gateway. Now similarly, for the other 192.168.20.10, 168.20.1. Now, okay, we have seen if I execute the ping command, now it again says the destination host not unreachable. Now, to make this as reachable, to make them communicate to each other, now here is where I will go to my first router. I'll go to my first router. Now, I will be defining the router. In the previous example, we did as EIGRP. Now, here we are talking about BGP. Okay. Now, followed with the same number. What is my AS number here? 10. So, I'll write this AS number as 10. Okay. Router process it like okay. Then now you're talking about BGP, right? BGP. Now I'll say that let's router ID. It can be anything 1.1.1, for example. It can be anything. You can give anything 1.1 router ID. Right. Now, after doing it, now you have to talk about its neighbor. Router 1 has the neighbor, isn't it? Now, what is the neighbor? It is 10.1 series. 10.1 is the neighbor. Okay. And its AS number is 30. That is what you have to clearly see. Boss, my packet will route through this particular network and whose AS is 30. Okay. Now that is what I am telling you. My neighbor is 10.10.10. What is the IP address that I have assigned to that interface? It is 1. So 1. Okay. And it has got remotely AS. What is the AS of that particular area? It is 30. Okay. Done. Neighbor is request of neighbor is sent. Now you say you have to advertise the address, right? Directly connected network. You have to advertise it. You have to advertise the directly network. So you have to write network. What is the network that you are associated with it? 10.10.10.0. Okay, and the mask that you give, the subnet mask is you gave as 255.255.255.252, isn't it? Now, for a network called 192.168.10.0, this is what your network, and it has got a subnet mask as 255.255.255.0, isn't it? Done. These are the 4 lines which you have to configure. You have to tell that this is your neighbor through which you are going to route, and you are associated with this particular networks in a router node. So coming out of it, okay, I'm closing my router. Now go back to this router and repeat the same process here. Repeat the same process. But when you do it, please make sure that you remember it. Router BGP. Now there it was 10. Now here it is 20. Here it is 20. AS number. Okay, 20. Now here you will say BGP. Sorry. Router ID. As there I gave as 2.2. No, sorry, 1.1.1. Here I am giving it as 2. It can be anything as it will. Then I have to again tell him, okay, this is what my neighbor. So what the neighbor for this particular area is, the 20 area is, what is it, sir? It is 20, isn't it? So you have to say that my neighbor is your neighbor 10.20.20.1. Okay? Then you should say remote AS. What is the AS? It is 30. It is the 30. Now similarly, you should tell that network called 20.20.20.0 has a subnet mask as 255.255.255.252. Okay. Now similarly, you also have one more network called as 192.168.20.0. I'm not wrong. Yes. Then its subnet mask is 255.255. Sorry, you have to again write its mask now. Subnet mask as 255.255.255.0. Okay. See, 168.20, correct. So both routers have completed, telling that this is the router, this is what is, then we are associated. Both told. Now this router should also tell that you are my neighbors, no? Now go to this router, and repeat the same process that you did for your router. But here, only change here is router. You're talking about the BGP protocol. Now here, what is its case? It is 30. 10 was completed, 20 was. Now you are into an area called 30. So 30. Now here my BGP router ID could be 3.3.3.3. Okay. Now I am saying it to be as the neighbor which I have to this router is, what is it, sir? How many neighbors? Sir, to this router, it is 10.2 and it is 20.2. That means you have 2 neighbors. That means you have 2 neighbors and 2 networks for this. Very, very important. For this area called 20, we have 2 neighbors and 2 networks. So now, let's define it. So one was, it is 10.10.2, 2, and I'm saying it's remote AS. 10.2 AS for which, sir? It is 10. So provide that AS number. Okay. Now similarly, see, it is up now. If you see the urgency is now up. It's in CC. The neighbor is up. You. Now similarly, let me do it with the other network, which was 20.20.20.2, and my remote AS will be, now the idea will be 20. See, it is also up. But 10.2 it is up, but 20.2 is also it is up. Okay. Now the neighbors are already established now. Now tell the router, okay, you have the network associated as 10.10.10.0 with subnet mask as 255.255.255.252. Okay. Now similarly, the other network called as 20.20.20.0 subnet mask as 255.255.255.250. Okay. Yeah, done. Fair enough, sir. BGP. Now you want to check. Okay, running configuration you do, no? So you write exit. You can also come here and you can say show IP interface. So you have all this. Now you can write here show IP BGP. Okay. So IP BGP. What do you want to see in BGP? Its neighbor. Enter. See, you are all its neighbors only. See what it says. The neighbor is this one, first neighbor. Okay. Now let's talk about the other neighbor. Other neighbor. Where is it? Other neighbor. You go down. It also talks about address tracking. See, it is talking about the other neighbor. Then this is the one neighbor and this is the other neighbor. See, it's talking about they have got two different neighbors. Okay. Now you can also talk about show or your IP BGP summary also. You also have summary. Okay. Now there you will see. See, this is your neighbor 10.2, 20.2 is your neighbor. Okay, whose AS numbers are given. Now this is where we can look for the testing purpose. Has that been configured properly or not? So now we have different AS configured and neighbors is also established. Now let's talk about go to this PC, go to command, and now here you are playing 192.168.20.10. Oh, sorry. Here is the ping 192.168.20.10. But for a second, it will respond you. See, it is responding. Okay. Like this, if I happen to add a server, see, I'm adding a server here. Now, go to media, see, Ethernet, and I'm saying it to be as first add it, must to forward, all the clear. Now, let me assign the IP address here. Let me assign the IP address to this server. Now, it is in the network called 192.168 dot, it was 20, right? Now, I will say 20.30. Now, it also has got the same IP gateway 20.1. Now, if I want to, no, let me ping this. so that you will enter 192.168. What was it? 20.30. But it's newly added, no? Come on, see. It is also responding, whatever. Okay. All right. Now, when you do this, now if I go to browser, now since that I am talking to a server, go to browser and type its IP address. Let's see, will it respond at 20.30? Because it's a server, it should give me the answer. See. Now this is where it is established. So the main aspect is this is one ISP, this is other ISP you can directly down. Yeah. Simple example before I close this. See, we have an Airtel here, Airtel communication and Geo communication. Now there are some areas where you do not have Geo network, there are some communications where you do not have Airtel networks. But still you are able to communicate. There is where we talk about BGP implementation. Fair enough? Now, this is what a small glimpse at the EIGRP and the BGP routing protocols. Thank you so much. Believe that you have understood it in the very short span of time. So I would request Kumar sir to please take over.
Thank you, sir. Thank you for your valuable session.
Okay.
It's very useful for the participants. Actually, we have recorded all the sessions,
Okay.
and we'll be sharing the session recordings to all the participants.
Okay.
And any participants, if you have any queries, you can ask. Else, we'll go for a break.
Okay, sir. Sir, I have a quick meeting now at 3:30. If you don't mind, can I?
Yes, yes, sir. We'll closing, sir.
Okay.
Thank you, sir. Thank you for your
Thank you so
presence.
much. Thank you so much, sir. Thank you, sir. I have taken your much time, sir. So thank you, dear.
No
Wish
issues.
you good luck. Right. Nice.
Thank you.
Nice.
Thank you, all the participants. This is the end of the session, and we are closing this workshop today. And as said, I'll be sharing one feedback form along with the quiz. So to complete the quiz, the certificate will be issued as mentioned in the brochure and mail. Thank you all.